Hey YouTube, fellow math students and math teachers, DeVore here again, working through the next task in the Mathematics Vision Project Math 1 curriculum. We're still in Module 1 and we're going to be tackling the task Elvira's equations. As you can see on the warning that I put on this, please make sure that you have serving up symbols at the very minimum done before you even think about working through this task. The reason why is because you will need all of those symbols from that table at the beginning of the task. Make sure you have it handy, make sure that you have it somewhere accessible, that way you can use it as reference. We have Elvira again. She is writing equations to describe some relationships that she might want to be able to talk about. And to do that, she might need to make some new units. She has invented a new variable she's calling A to describe the relationship below. We have A equals S divided by CP. Now remember that S, C, and P are straight off of our table from serving up symbols. And also remember that since we are doing multiplication and division, we want to use the rate unit, the one with the fraction. It just makes it so that we can see what's really going on. Alright, so let me see here. We've got A equals S is student per day. And you'll notice that I'm breaking up the fraction a little bit. That's because if I were to write fractions on top of fractions, it gets very messy. I actually prefer to write them side by side because it makes them a lot easier for me to read. It also makes it so that when I'm doing the fraction stuff, all the cross canceling, I already can eyeball some of it from where I'm at. It's just an easier thing for me. It's much more convenient. And then C stands for classes per lunch period times periods per day. Now you might remember from our work in examining units, we can see right away there at the bottom of the fraction that we can actually do some cross canceling. Let's go ahead and do that before we get too much further. And we're not going to start the division process yet. We're just going to simplify the bottom part of our fraction. We end up with class per day. Alright. Now remember that when we are dividing fractions, we don't want to divide fractions. Instead, we want to do keep, change that to division, and then flip our second fraction. And again, since we're multiplying, we can see that cross-canceling happening. So A equals student per class. A then means the average number of students per class. And that's a good thing for her to know, because if you know how many classes have lunch at a certain time, say you're at a high school in which you have a lunch period that's an actual period, say like fourth period lunch. That's essentially what she's doing. If she has an idea on how many classes should be in the cafeteria, she can eyeball how many people, how many students should be getting food. Part 2 says, we're using what we know about manipulating equations. We want to solve our original expression right here for S. And it says our solution will be in the form S equals something with variables A, C, and P. Okay, let us rewrite our original equation here. A equals S divided by CP. If you notice, we have S on the top of our fraction, and then S is being divided by CP. CP, remember, is just a number. If I want to undo division, I need to multiply, which means I'm going to multiply both sides by CP. So let's go ahead and do that. We're going to multiply by CP equals CP times CP. Now remember that when we are undoing the division with the multiplication, everything, all the CP's on the right-hand side of our equation actually cancel out, leaving us with ACP equals S. Or we can flip that around if we want to be have it a little bit easier for us to read. Saying that S equals A times C times P. Okay, that's pretty straightforward. The question 3 is now asking, does this make sense in terms of what our quantities, what our rates actually stand for? Because remember, we need to keep track of our units. If our units don't make sense, then we'll do all the math for nothing. What we're going to do is we're going to take this equation, this S equals ACP, and we're going to now substitute in those rate units so that we can make sure that everything cross-cancels like it should. We have S equals, we have student per class times class per period times period per day. I see a lot of cross-canceling. We can cross-cancel class. We can also cross-cancel period. What we're left with then is S equals student per day, which is exactly what we started with. We should be able to look back at our table and say, oh yeah, that's what it should be. In this case, it does make sense. Because we got the same thing back that was on our table, now this makes sense in the context of what we've been working with before. This fourth part wants us to solve for C. I am actually going to start here. This is a valid place for us to start. ACP. And the reason why I'm starting here is because in the original equation that we were given at the very beginning, C is at the bottom of our fraction. And in order for us to get C by itself and out of that fraction, we'd actually need to start here. We would do this process, we would get here and then work with it, so this is just saving us a couple of steps. Here we have C, and C is being multiplied by A and P. To undo multiplication, we are going to divide both sides by AP. Here's what this looks like, ACP divided by AP. In this case, the A's cancel and the P's cancel on the right-hand side, and we are left with C equals S over AP. And the question is, why, does this make sense in terms of the variables given? And to show that, we are going to go ahead and do the same thing as we did above, where we are going to plug everything in. We have students, if I could type that'd be great, students per day, divided by student per class times period per day. And the fun thing about this is that you notice that we can't actually start canceling a lot of this stuff. Let me just make absolutely sure here. Yeah, we can't really cross-cancel like we were able to do in the first one. So when we do our keep, change, flip, we keep this first fraction. And when we flip, we're going to flip everything in brackets over. Here's what we end up with. We end up with class per student times day per period. And now we see some things that cancel. We can see that these students cancel, but we also see day cancels. And we are left with C equals class over period, which is what we should get. Yeah, we should get class over period. That is straight off of our table. Therefore, this makes sense. This expression that we came up with makes sense in the context of our variables. Okay, we're going to do a similar kind of thing here. Here's our second equation here. We have T sub S equals S times NE plus NS plus NB divided by I. Now this is where Elvira gets a little bit clever, because she realizes a couple very important things. She knows that when she is counting students per day, she's really counting the number of lunches that are sold. right? She's really counting that. And when she's counting up the number of entrees plus number of side dishes plus number of beverages, she's really counting the total number of food items in a lunch. Just generically. Let's break that down then. We end up with T sub S equals, on the top we've got lunches times, and then we've got items per lunch. This is all on the top. Divided by lowercase I is items per minute. Alright. Now, even though this is kind of a bad thing on my part, you really shouldn't make these things plural. You should try and make everything singular because that actually makes it easier to read. What you should notice is that on the top, we are now able to cancel out lunches. Yeah? We are now able to cancel out lunches on the top. Here's what we're left with. T sub S equals, we've got items divided by items per minute. And again, if I could spell, that'd be fantastic. There we go. Now we're going to do the same kind of thing that we've done in the past, where we write it out in two separate forms. We have items, and because we don't have a fraction there on the top, we're just going to put a placeholder of 1. And then divided by items per minute. We do our standard keep, change, flip. And you can see that we can now cross-cancel items. This leaves us with T sub S being the number of minutes. Now, it's important here to distinguish what kind of minutes are we talking about, and for that we need to go back to what our variables actually mean. And when you look at minutes, if you look under lowercase I, it's serving minutes. So this is really minutes to serve a lunch. That's all it is. How many minutes on average does it take to serve lunch? Which is really important because if you're taking too long to serve lunch, maybe you need to hire on more workers. Maybe you need more lines. You have to look at what the holdup is. That's very important for any business's bottom line. Okay, we are once again going to use our mad algebra skills here, and we are now going to solve this equation up here for S. Let's go ahead and rewrite it. That way we have something to work with. This is what copy and paste is for. Copy, paste. There we go. We have S here on the top, and we are dividing everything by I to undo division. We multiply both sides by I. Times I equals S N E. It would really be fantastic if I could spell today. I do seriously know how to type. Okay. And remember that everything in here, this is just a number of food items. So we can divide everything by that number and still have it make sense. Here's what we end up with, and it's a bit of a monster. S equals, on the top we have T S times I divided by N E plus N S plus N B, and that's it. And I am going to leave part 7 to you, as well I don't know, let's do part 8 together and then we'll end the video. So we're going to solve our equation for NE. And I am actually going to start from part of the equation that we had up above. We have TS times I equals S and E and S and B. And what I'm going to do is I have my number of students times my number of food items. Those are both just numbers. I'm going to divide both sides by S. Here's what I end up with. Again, if I could type, that would be fantastic. Equals. And now we can take everything out of the parentheses, and it's going to be a lot easier to see what we need to do next. Since I want to get NE by itself, that means I need to move over my number of side dishes plus my number of beverages, and we can do that by subtracting. Here is what we end up with. Times I divided by S minus number of side dishes minus number of beverages. And there we are done. Alright. So that is Elvira's equations from the Mathematics Vision Project Math 1 curriculum. If you have any questions, please feel free to stop during my office hours or to send me a message or send me an email on this channel, and I will help you out as best I can. So this is Mithrilla signing out, and remember, be awesome.